Thank you so much, folks, for coming. I see Rachel is on. She's going to help me moderate questions. Let me just share my screen for a minute. Here, this is our Shield webinars. Before I go around and present our two rock stars, Nancy and Fran, just for you guys to know, it's very informal, super informal. This is our fourth webinar. And the idea is we are all, even though in Zoom, sitting in our couches having coffee with Nancy and Fran. And I send them some draft questions, but if you come up with other questions and if you have other comments, I think there will be plenty of time for us to discuss. And this I will show you where this idea came from. So first of all, those in the poster, I don't have to present you folks. You all know how amazing these two are. Nancy Crooker, and in the poster you had her bio as well as Fran. She started a postdoc in Cornell. This is where my sister was actually. And then in MIT, and she worked with John Feynman. And then she went to UCLA. She worked in the magnetosphere, in the heliosphere, so many different amazing fields, also CMEs, these seminal works. And she ended up being a president of the AGU. She's also a fellow of AGU. And one of the ideas of this webinar came from her prize Eugene Parker lecture. Whoever joined, or if you can mute yourself, I thank you. There's a lot of noise in the background. So if you can mute, would be great. But anyway, Nancy gave a talk where she described how to make discoveries in general. Was not about her work, but about other fellow scientists that were very visual. So she gave a lot of examples of visuals, including Margaret Geller, that discovered the pattern of galaxies from washing dishes, from the pattern of the foam in the sink. And I was like, oh, this is so cool. I'm very visual, so that would at least inspire me. You can be a scientist, make discoveries from other means, and then find the mathematical framework to frame it. Anyway, so I'm looking forward to hearing from her. And then Fran is incredible as well. She started her PhD in Voyager. That is great. She sent me an amazing picture of her and Margie right back then in the Voyager. Anyway, she started in the plasma science experiment when Voyager went to Jupiter. She did her postdoc in Imperial College, and she came back to US to work at the University of Colorado with the Voyager flybys of Uranus and Neptune. And she was there a professor until 2015. So besides Voyager, she's been in incredible missions like Galileo and I know she's involved now in New Horizons. So I'm looking very forward of her take on how discoveries are made. And I just wanted, before I pass the floor to Nancy and to Fran then, just to remind you what SHIELD is about. So this idea of this webinar came from this Drive Science Center that was funded for phase 1. We hope we get phase 2 from NASA. This is part of the decadal survey for centers that tackle some strategic science themes that needs a big, large center. John Richardson, is a PM. And the goal of SHIELD is, the SHIELD stand for solar wind with hydrogen ion charge exchange and large scale dynamic, is to have a predictive global model of the heliosphere. It's pretty lofty, and what we are trying to do our best, but we have this website here that you can go and check on all the great science we've been doing. And the drive behind it is that, you know, we are habitable, our astrosphere is habitable, and by studying, sorry, I'm trying just to mute here. By studying our own heliosphere, we are laying the groundwork to predict what habitable astrospheres look like. And we have this website where you can check all the research and outreach. We have, in terms of outreach, an amazing series called Testimonials. If you can mute yourself, it would be great. Good. So we have a series that started, You Can't Be What You Can't See. And touching in this point that if you look around, even this room, there is not a whole lot of diversity, not in gender, race, et cetera, et cetera, et cetera. And so we ask graduate students all over the institutions related with SHIELD to talk about their experience, where they come from, what their challenges were. And based on some of these testimonials, we started this webinar series, is why it's maybe difficult to be a woman from imposter syndrome. Men also suffer from that. There's also another webinar we did about immigrant experience, people that think in a different way. And I think the webinar today will touch on that. So we're trying to pick universal themes and bring it amplified in webinar form. At the end of this webinar, I'm going to send this link around, or Rachel as well will help me. If you can fill out this survey, will help us prepare next webinars. What do you want to hear? What you like, what you didn't like. So will help us prepare for future webinars. And stay tuned. We're going to launch the SHIELD Happy Hour. We have this cool logo that Costas Dailinas made for us, that where you can bring your own drink and come and mingle with us. Okay, so I'm going to stop sharing and give to Nancy the floor. Thank you.
Okay, so I will start sharing here. And play. Okay, so Marav has asked me to tell you how it is that I did physics, how I did space physics, and in her words here, how I found the needle in the haystack. And I can answer that with 2 words, and those words are pattern recognition. Now, in the broadest sense, pattern recognition is what we all do as scientists. Here's a definition by Addie Pross in his book, What is Life? For those of you who don't know this book, he picks up where Edwin Schrödinger left off in a book written in 1944 with the very same title. So he talks about pattern recognition as being the heart of the scientific method, the process of induction, formalized by Francis Bacon way back when. It's a generalization from a set of observations.
Embaixo.
Pardon me?
Na gaveta.
Oh,
Go ahead, Nancy. I'm muted. It's fine.
Oh, okay. The generalization is a model or a recognized pattern. Another definition here is from Donella Meadows. She's famous for systems analysis for her book, Thinking in Systems, and she has a very broad definition. Everything we think we know about the world is a model. Every word in every language is a model. Maps, statistics, books, databases, equations, computer programs are models. So are the ways I picture the world in my head, my mental models. And for me, it's that last statement that is important. Here's another definition by astrophysicist Margaret Geller in her Phi Beta Cap address at Harvard. She said, in order to understand, the scientist makes a model, a picture, an abstraction, which contains hopefully all of the important properties of the natural phenomenon. Often the picture is cast in mathematical language, Whatever the description, the scientist sees the picture and views it from many perspectives in the mind's eye. Again, that last sentence is what resonates with me. Now, sometimes a pattern can be quite simple. It can be a correlation. And the reason I'm showing this particular correlation is it was done by Henrietta Leavitt in 1912. And I think that her name is not well known at all. I don't believe she's gotten enough credit for what she found. She was one of those hidden figures, the human computer at Harvard Observatory. And she did drudge work, routine work, looking at these glass plates of photographs of stars. But in the course of her work, she noticed a pattern. And what she found was that the brightness of variable stars is proportional to the period. Now, variable stars are those that change their brightness from dim to bright to dim to bright. And so she found that both the maximum brightness, that's the top line, and the minimum brightness, the bottom line, are proportional to that period. And the reason this was so important is that it gave us a handle on how to measure the distance of stars. And it was immediately used by her boss, Harlow Shapley, to deduce that our sun is not in the middle of the Milky Way, the way people thought it was. It's off to the side. And Edwin Hubble deduced that the Milky Way itself was not in the center of the universe, as people thought, but off to the side. Most famously, of course, Edwin Hubble used this correlation to demonstrate that the universe is expanding. Here's Margaret Geller's pattern. Merav has already mentioned this. Margaret was one of the first people to measure the distribution of galaxies. And at the first go, they thought the measurements were in error because they were showing that it was not uniform. The expectation was that the distribution would be uniform, and it wasn't. And famously, gazing into her dishpan of suds, she recognized that what she was looking at was a distribution of galaxies on the surface of spheres. So it's like soap bubbles. And this, her later work, which covers almost 1 billion light years here, you can see the suds that she was observing. Closer to home, we have our own Merav's pattern here on the cover of Nature Astronomy. With her MHD modeling, she's shown that the heliosphere is crescent-shaped, not comet-shaped, the way it was expected to be. Now, my own pattern recognition came with analyzing data. And I started out in the magnetosphere, and what I like to do was to determine the shape of things, let the data tell me, to figure out what is the shape of things, what is their form, in other words, phenomenology. That was the kind of thing I like to do. And I switched to the solar wind because a lot of the phenomenology in the magnetosphere had already been done, whereas it seemed that there were a lot of openings left in the solar wind. As an aside here, I'm going to answer a couple of questions that Merav posed to us about mentors and about alpha males. These data were analyzed spectacularly by Jack Gosling, and he was a leader in the field at the time. And so he essentially became my mentor, and I did not find it difficult to find mentors in our field, albeit it was mostly a choice of different males. But I was careful about not choosing someone with a big ego. That bothered me a lot, scientists with big egos. In general, in the hierarchy of sciences, where the environmental sciences are near the bottom and the high energy physics is at the top, the egos increase with height, and the participation by women decreases with height. We can even see that within our own space physics, which is, in general, I think space physics is relatively easy for women because we are near the bottom of that hierarchy. But within our three fields, ionosphere, magnetosphere, solar wind, my experience was that there definitely was a hierarchy there. I always found ionospheric physicists to be so compatible, so used to working in teams, sitting around a table, talking about things. Very different from the egos that you see elsewhere. And in the magnetosphere, it was not quite as compatible. There were some egos in competition, but in the solar wind field, especially even before my time, so I was told, the egos were rampant. And here I was moving into that field. I wasn't comfortable with that, but Jack, of course, didn't have a big ego, and that was good, but he was used to dealing with that. And that was his method of communicating at meetings. You know, they would have these vitriolic kinds of things to say to each other. Jack liked to argue. Well, that was not my way of doing science. I did not like to argue. And so I made clear up front. I said, this is not, I don't want to argue. I want us to have civil discussions about the science. And he honored that. So that was fine. So we were off and running. So to get back to these data, originally, these were on microfilm, these super thermal electron data. I had a grant for Steve Kaler and Jack Osling to begin some projects together. So Steve and I went out to Los Alamos to learn how to use these data. And we sat on either side of Jack at his desk, and he went through reel after reel after reel, pointing out all the ups and downs and little details of these data and what that meant. And it was 2 days, for me, 2 days of real tedium. But for him, he was like a kid in a candy shop. I mean, he was so enthusiastic about these data. He just loved looking at them, talking about them. And of course, that's why he was so good at it. He really enjoyed recognizing patterns in these data. And after Steve and I learned how to do that, we were off and running as well. And there was another reason why I wanted to follow in Jack's footsteps in this field, and that is his papers were easy to understand. And one of the reasons for me was that he had always some kind of schematic drawing at the end of his paper to communicate what it was he was picturing. And for me, that picturing was very important. It was the way to understand what it was he was saying. And so I followed suit. And here is a raft of schematic drawings that come from a number of my papers.
I adore them.
And for me, this schematic drawing was actually an essential tool. I would look at the data, analyze the data, certain picture would be forming in my mind of what was going on, what it meant, and I had to sit down and try to draw it. And when I sat down to draw it, often in the drawing, I would see that there were some geometrical constraints I hadn't taken into account, or some magnetically topological mistakes I hadn't taken into account. So for me, it really was an essential tool, not only a good way to communicate. Some of the patterns that I came to analyze, to me, were just beautiful. These patterns here are from the Wang-Shili-RG model of solar wind speed. And each panel is successive in time, and it shows how the solar wind speed changes with time and evolves. And it's just an invitation to recognize some pattern. Why is it that these formations are taking place? And in the course of my work with these, I realized that there were two different magnetic topologies that give rise to the slow solar wind, and that they were connected in a certain way, such that you had then a web of slow wind being propagated out into the heliosphere. It takes imagination to do pattern recognition. But as my first mentor, George Cisco, pointed out to me, that imagination runs the gamut from what Albert Einstein had to say, that imagination is more important than knowledge, to what Richard Feynman had to say, that science is imagination in a straitjacket. That's quite a continuum. You know, Einstein was famous for his thought experiments. He would start by, picturing things in his head. And then he would collaborate with mathematicians and such to help formulate what the picture in his head was telling him. Whereas Feynman was a genius at calculations. And so he was constrained by the laws of mathematics and physics. Within this continuum, personally, my science fell much more on the imagination side of things. So in closing, since today is February 12th, and here in the US, we celebrate the birthday of Abraham Lincoln, lesser known to Americans, but pointed out to me by George Cisco, it is also the birthday of Charles Darwin. And I thought it would be appropriate to end this presentation with a tribute to Charles Darwin for recognizing the phenomenally foundational pattern of evolution by natural selection. So that is it for my comments today. Thank you.
Fantastic, Nancy. Love it. I have more questions for you. I suggest that we go to hear from Fran, and then we switch for open questions. Okay. And if you have already questions that you're thinking, please put it in the chat. And me and Rachel are going to go through them at the end. But it was lovely, Nancy. Yeah, lovely, lovely, lovely. Okay, Fran.
Okay, I'm going to share my yours. Okie dokie. There we go. Okay.
Oh, I love this picture. Yeah.
Excellent. Okay. So I'm going to, this is from the front of my Van Allen lecture, because indeed I want to emphasize this quote. If I have seen further, standing on the shoulder of giants. Of course, that's a quote from Newton about standing on the shoulder of Galileo. But for me, I would like to say that the scientific giants whose shoulders I have stood on are Margie Kivelson and Michelle Thompson, both also Van Allen lecturers. And here's a picture that we took in 2018 or so, something like that. But of course, all three of us are very short people. Anyway, okay, so I'm going to talk a bit about my interest in planetary magnetospheres. I'm not sure how the needles and haystacks work out, but we'll see how that goes. So a little bit about my history. I grew up in England. I was just a small kid in a small village and was curious about the outdoors and science. I grew up in the space age on TV, watching Apollo, staying up until 3 in the morning to watch the guys walking around on the moon. And of course, I watched a lot of science TV, including a lot of Carl Sagan, whom of course I worshipped, space exploration, him talking about the early exploration of Mars. I was actually very lucky to meet him when I was 16. And I was gobsmacked. That's English for speechless. And I heard him give a talk, and it was very interesting because this was at Cambridge University that my brother was attending, and my brother brought me along to hear Carl Sagan talk. And what was interesting was we had the English professors going, oh, you can't really say that this planet has volcanoes or such things, can you? And Carl Sagan would say very honestly, well, the evidence is here and the evidence is that, and you have to look at it and it looks like this is what we're seeing. So I liked the way that he gave a very honest, open discussion and was not intimidated by the very stuffy academics of the time. So that was an important lesson for me. So I came over to America in 1976, which is a very interesting time to come. It was around the 4th of July when there was this big 200-year celebration of kicking out the Brits. And I watched reenactments in Lexington. But it turned out to be the right place for me. And I got heavily involved in research at the Center for Space Research. And Voyager was just about to be launched. And I got wrapped up in the Voyager mission, analyzing the plasma data with the plasma group there. And was a lot of fun. The technology was a bit primitive at the time, but we were really excited by seeing all this amazing new data that was coming in. Now, I want to tell this story. I've told it several times, but in the AGU in 1979, the Winter AGU in San Francisco, where there was a big series of presentations on the Voyager results, you know, usual story, there's about 20 people presenting in a big room, I don't know, maybe 150, 200 people. Carl Sagan was the chair. And there were 3 women who gave presentations. There was Margaret Kivelson, there was Nancy Crooker, and there was me. And you can see over on the right, we used PowerPoint, not PowerPoint, sorry, PowerPoint didn't exist at that point. We used overhead transparencies or slides, and so very crude graphic presentation, as you can see. But I want to tell you about these 3 women. And so first there's Margie Kivelson. And she was immaculately dressed with a beautiful hair and earrings and makeup and a lovely dress with hose and high heels. And of course, she gave an amazing talk, just full of all the solid science that she does. Then there was Nancy Crooker, and she had bouffant hair. Remember, this is 1979. Okay, and she had a pantsuit on and a fluffy blouse. So, and then me, I wore, honor of Carl Sagan, I wore a polo neck sweater and jeans. Well, I had corduroy jeans, so those were dressing up for me. So you can see just from the outfits, society was changing really rapidly at that time. But it was interesting that in looking at Margie Kivelson, I could see nothing that I had in common with her. And she seemed very different from me, and I couldn't imagine myself being her, right? Ironically or fantastically, we became good friends. And the lessons from this are, don't judge somebody on first appearances, even though they may seem to look very different from you. You may end up finding a lot more in common than you first realize. And the other lesson is that society changes, and these changes eventually get reflected in science and academia. So just be persistent, because although things may seem one way at one time, they can move on and get better. Okay, so after I got my PhD, I went back to England for a postdoc, and I worked at Imperial College for a while. And in the mid-80s, I was faced with this dilemma. I was torn between staying in England and living in London, which has its pros and cons, versus going and coming over to Boulder, where I could go rock climbing and be outside. And this is a sort of classic personal and career decision that people have to make in their lives. And you have to weigh it up, you know, the location, the science opportunities, the career opportunities, your personal interests, and so on and so forth. Well, I was very lucky. I chose Boulder. I was offered a faculty job. There was space exploration going on in the US, so I wanted to come back to the US. Oh, and there just happened to be this climbing partner who just happened to live in Boulder. So I ended up in Boulder, and I was lucky that these things came together for me at the same time in this way. When I know many people struggle with having to find a work-life balance or finding a career situation that allows them to match their personal choices and their careers. Okay, so let's talk about, I've been instructed to talk about looking for a needle in a haystack. To be really honest with you, my science that I do is less about looking for needles in haystacks, more about trying to understand different haystacks. So in this case, it's magnetospheres, and looking at different kinds of magnetospheres, how they fit in the heliosphere and how they work. So, for example, these huge range of scales and slightly different structures associated with these different magnetospheres. And here I have to thank Steve Crusher Bartlett, yes, my climbing partner and personal partner for the past many decades, because luckily for me, he also is an expert in graphics. And so this has been a huge advantage for me that I've had him helping me put my graphics together. So here's an example of the several papers that I have written on comparing magnetospheres. And the one in the middle that I wrote with Jim Van Allen was a huge honor to be working with him. But you can also see that I wrote a chapter with Margie Kivelson. In fact, there's probably 2 or 3 that she and I have done. And what we've done in these articles is to pull together, if you look at all of the planets across the solar system, different objects, and you think about their properties and you compare their properties and try and understand their magnetospheres. And this is a table with all the numbers, but the point is we really want to do is to think about how their different properties, such as their magnetic fields, how they vary, what that means in terms of the size of the magnetosphere, and then looking at the structures and their behaviors. What does this mean about the physics, the underlying physics of these different objects? How they compare? What makes them similar? What makes them different? How do we relate to the physics of what could be happening to what we see when we look in the data? We fly through these. My experiences in combining in situ measurements as we fly through and measure the plasma properties with remote sensing, such as emissions from the EO plasma torus or from auroral emissions and things like that, combining these different ways of looking at something and working out what the underlying processes that are there. So I want to give you 5 pieces of advice, and this is the first one. And I learned this from John Belcher, told me that this was a piece of advice that he passes on, which is don't be intimidated by other people's qualifications, which sounds a bit funny, but really what it is when you walk into a room or a situation, you move into a new career, move up, say, enter grad school or become a postdoc somewhere, and you meet other people who seem very brilliant and they have all sorts of qualifications and they're not frightened of telling you what they know, relating to Nancy's mention of the hierarchy of egos that seems to be in slightly different fields. But the point is, don't be frightened by these people. Your curiosity and asking thoughtful questions and being persistent is just as important as those egos. So this is also related to the idea of don't think of yourself as an imposter. And indeed, imposter syndrome is very common. I think I finally, when I got tenure, I threw it off, but it took a long time. It's quite common. So I too want to mention George Cisco. He was very involved in the Voyager early observations of the magnetosphere. And as I was preparing and getting ready for Voyager arriving at Jupiter, I read his papers, such as this one on Jovian plasmaspheres. And I read through the equations and tried to understand what was going on and pulling things together. And he had a very comparative approach to looking at magnetospheres, and I learned a lot from him. But what was interesting, and the piece of advice I want to pass on from him, was at a summer school that he ran for graduate students. And I was a lecturer at that summer school. He asked a question of somebody who was throwing all these equations out. Can you give me a push-pull explanation of that which you're showing here? And so the point here is that equations are important, and yes, you need to use them to understand and do the physics, but it's just as important to be able to explain what you're doing to any intelligent person, right? You learn more by being able to explain and give a push-pull explanation how something works. And so don't be frightened to ask a speaker who's blathering out all of these equations to say, could you give me a push-pull explanation of what you're talking about? So, next piece of advice is it's important to take some time out for deep thought. It's not time out, it takes some time. It's important time, it's primary time. Because you've got to be aware of doing too much and too shallow. So turn off your email, turn off your phone, and make sure that you're getting lost in some creative activity, whatever it is, whether it's data analysis, developing theory, writing paper. But it's important that there are days when you are so involved in what you're doing that you don't realize, oh my golly, look at the clock. I just spent 2 hours working on this. It's very important because that is an indication of creativity. That's an important thing. Okay, another piece of advice. Think about, for your career, what's next around the corner. And right now, we need to go back to Uranus and Neptune. We need to go back to those weird and wonderful magnetospheres. And so we need to think about how these weird magnetospheres work, okay? And so we need to think about campaigning to get back to Uranus and Neptune and what kind of instruments we would take, developing models. These are a couple of animations of these weird magnetospheres. We need to be ready for going there. So get involved, you junior scientists, on what you could be doing down the road in the future, and start to get involved in that. My last piece of advice is when to say yes and how to say no. This is about service work. And I wrote a longer piece, not very long, a couple of pages, on this in a blog for Women in Astronomy. I urge you to go look at this link. But the point of this was to say, we need to prioritize what we're doing, particularly women and minority populations are asked to be on this committee and that committee and the other committee. And would you do this? And would you do that? And would you do the other? But everybody needs to decide what is important to them. What do you want to do 10 years from now? Is your research success the most important thing that you need to focus on to get you into the career that you want? Or if it's service, then where will doing all this service work lead you? Where will it take you? What career path will it lead you down? So when I get a phone call from someone who says, would you be on this committee? Would you be on that committee? And now I always wait 24 hours. I say, I'm sorry, I have a policy not to respond immediately to your request. Thank you very much. Let me get back to you in 24 hours. And this gives you time to do two things. If you want to say yes, then you've got to drop something else, right? You mustn't accumulate large quantities of service work, okay? You know, if it's an invitation to give a talk at an important conference, sure. But if it's yet another committee that you're being asked to be on, maybe to be the token woman, then, you know, this is a problem. You've got to be careful not to take on too much. And if you say no, then you can, gives you time, 24 hours to think, oh, well, I can suggest so-and-so, or I can suggest such and such, somebody else instead of you. Okay, so be careful. So I want to end with the last slide that I showed at my Van Allen talk. And this has the many, many people who have helped me over the years in science. And in my career, they've been mentors, they've been friends, and helped me get through science and move on and do all sorts of fun stuff. So with that, I'll thank you very much, and I'll be happy to answer questions.
Guys, this was so phenomenal. I have so many questions, but instead of me starting to flood you, I want to open the floor and for questions. There was so many in the chat. I didn't really read them. If somebody from the chat want to start, Heather, you want to say something? I see that you wrote some stuff, or if somebody else want to ask questions.
Yeah, I thought it was really interesting that Nancy focused on pattern recognition, because it was just a few years ago, I figured out that what was in common with my hobbies and my work was pattern recognition. You know, like as a kid, like I used to love music and sing a lot. And then I started writing like song lyrics and poems. And then later in life, I started doing dancing, and that's like about taking patterns in the music and making them visual. And then since then I've gone back to looking at complex patterns and Middle Eastern rhythms. And so actually would like to make an argument that if you have hobbies, some of the skills can translate in ways that you really won't quite foresee. And like pattern recognition is something that can show up in a lot of different places. And then as Fran mentioned, finding common ground with people, it can take a variety of forms. Somebody doesn't have to look like you. They don't even have to do this exact same work as you. But a lot of times what it takes is talking to somebody one-on-one, and often you'll find that you might share a hobby, you might actually share a common interest that you didn't foresee, and you would never know about it unless you tried to have a one-on-one conversation. And then another thing, like when I switched from magnetospheric to heliospheric, I did feel a little like an outsider in that I was like the youngest person, and there were very few women, very, very few. But despite that, believe it or not, the heliospheric community seemed very fair in how they treated people. When they were critical, it was about the work, about the science. It wasn't any personal attack or anything like that. And you saw that even, people of similar stature in the field would criticize each other, but it was the work. It wasn't like they're personal. Nothing about it was personal. And if they were criticizing your work, that actually meant they were interesting. The worst thing is if nobody says anything, nobody asks you anything. You actually want that response back.
I have a quick question, and then I'm going to open for more questions of the audience. I think you, Fran, and Nancy, you answer it, but I want just to reiterate a little bit. I think my question that I sent you guys by email, if you think the gender maybe played any role on the way you approach science, and maybe not, maybe, and I encounter so many other guys in science that think like me, that are just more autistic and think about science in a more visual way. But so it's maybe not the gender, maybe you can rephrase it, is so much of the language that you see in science is you present a very solid logic with equations and go for argument A to B, and you need to hide any intuition, any visual intuition, any other. And so this is and I remember I have a story that when I started collaborating with Jim Drake, and he's very precise, and I will tell him, I know the answer. And he said, how do you know? And he will ask me all these equations. And I said, forget your J cross B. I know it is. And he would say, where the current is going. I said, no, I see it. And then we will go to the blackboard and said, oh, you were right. But I came from a different intuition, and took us many years to translate our language. And now, because I work with him so many years, I say something, say, you're right. But it took us many years. I felt like I was, and again, it was close to my heart, maybe coming from different cultures, that minority, if you want to say, that you come from a field when there is a predominant language. And if you speak in a different language, not hide it, but, so it's coming to what Fran you said, don't feel overwhelmed, but be willing to translate your language, or, stick your guns at,
this is exactly the what I learned from George Cisco's phrase of push-pull explanation, asking for a push-pull explanation, and not being afraid of asking for that, and that's important, because it gets you to translate what those equations are into some feel for what's going on, which is, I think, really the same sort of thing you're talking about in terms of intuition. And in some ways, it's like you could say push-pull explanation, or draw me a diagram, right? Those lovely diagrams that Jack together for Nancy, it's the same sort of thing. You could say this is finding a pattern, or but it's moving beyond those.
But in some sense, it's bringing a more diversity of thinking.
Yeah.
For the science, that you bring people that think differently.
Right.
That the language is not uniform. There's no one single way. And if there's not enough equation in the page, I won't,
Yeah. Well, the people that are good at doing the diagrams and the cartoons are often some of the best communicators in our field.
Yeah. So did you encounter that, Nancy or Fran, some resistance, or Fran, when you do the comparative, and Nancy with the drawing, and feeling this is a more softer science, give me the equation for you to prove me. So you know what I'm talking?
Right. It was cartoon physics.
Exactly. Yeah.
Accused of doing cartoon physics, but you kind of have to brush that off.
Right. Okay. Anybody has other questions? I have my list but I wanted to open up.
Well, actually, I wonder if Fran could talk about working with her husband on the cartoons and the diagrams.
And Nick, I see, raised his hand too. So
yeah, no, it's a great pleasure. He's not a scientist, and so it's actually quite useful, because if he can understand what I'm drawing and I want to make it work, then then the students will understand what I'm talking about, right? So that works quite well, and he's more visually more of an artist than I am, so it's great. It's sometimes I need something for tomorrow, and I'm like, oh, could you just take this diagram and adjust it? And there we are.
So I see questions from Nick, and Judy Carpin also said, and I would like to hear also from Judy, I know when you're mentoring other people in Goddard. Anyway, you want Nick and then Judy to ask a question?
Sure. It's sort of a following on the theme of drawing. I wonder if we kind of beat this out of our students sometimes in a way, or don't more importantly, don't reward it as part of an evaluation, right? As part of an assessment, and say, hey, before you like get into the triple integrals that you have to do to solve this, draw me a picture and show me that you've set it up right. So I'm curious to hear other people's responses to that, whether that's there should be more incentive or more evaluation of people's ability to visualize something.
Or brain from a different views. Right, go ahead.
Yeah, I think it's one of the casualties, unfortunately, of Zoom is that, it's very difficult to do the drawing on the blackboard or going to the whiteboard and drawing stuff. And I very often, will hold up a piece of paper like this to the camera, it's very frustrating because you can't, do the things that we normally do.
But in a bigger picture, Fran, even without COVID before, is having, I think Nick raised an interesting point, is I think as my students that are used to working with me, they got used to my style, that I'm a big picture person. I need to see where you're going and then show me the equation. And so, but I'm not sure.
Yeah. Well, one thing I do, it's not a cartoon or in the sense that what Nancy was talking about, what I try to imagine what the plot will look like when I do a different data reduction step, because I do mostly data analysis. And then it helps me debug code, because, or then it's just not the way I think. And then I have to go back and rethink oh, okay, it's not happening like I expected, but it really looks like I coded it right. And it really makes you think a lot, but also imagining what it might look like. Then you're making tweaks to the plot without having to code them. And so it's much faster to do it that way. I've been teaching my students that, they're picking up on it.
I see that we have Emily Mason raise her hand. I'm just mindful of the time, and maybe Adriana or Chuck Holmes, you want to say something? I see some comments in the chat. But Emily, you want to ask first? I just want to hear from people that didn't speak yet.
Yes, thank you both for talking. I just wanted to know, Nancy, do you think there's still room for that kind of top level data analysis, like pattern seeking in solar and helio data?
Well, I've been retired now for several years, so I'm not good at speaking to that. When I left the field, there still was that. But I don't know, I guess I feel that probably there always will be. There always will be data people haven't looked at in a certain way to get certain pictures. So yeah, I guess I would guess yes.
But I would say also it's important in theory and in modeling to have that visual or that intuitive, that push and pull explanation before you start. I feel I like opera, so I don't want to hear the soprano go, all the beautiful mathematics, Can I know where you're going from? So if you cannot explain it, push and pull, something's wrong with the math. Yeah.
I like Heather's point about when you're analyzing data and have some sense of what the plot's supposed to look like, or when the plot comes out and it doesn't look like your prediction, your immediate reaction is DTMS, does this make sense? Okay, I always would write this on homework when the student would produce a totally batty number. And you need to check, does it make sense? Does it make sense? And so I think your point, Heather, about before you plot the data, just some sketch of what you expect it to look like is very important and very helpful.
Yeah, well, I actually made a conscious effort to teach that to my student. I just sat down with him, several times, hey, let's just draw out stuff. And at first he was shy about trying to draw it himself. But then what eventually happened is he started to draw it himself. And then when I got the plot back, when he was making changes after he made changes to his drawing, and then he programmed it up after he had done iterations and drawing, it was a really cool plot. And it illustrated the points he wanted to make so much more clearly. I mean, he made like a big leap in how good his plots were when he did that.
Yes, okay, folks. Before we have another 5 minutes, Rachel put in the chat a survey. We are going with our gut feelings of the main issues. But if you have certain particularly issues that you want to hear us, if you can fill up this survey and tell us if you have something for the discussion, that will help us plan for the next webinar. Anybody has another comment before we have to wrap up? I have a question then that Nancy and Fran didn't really answer me. Well, how was in those years, I know you said, Fran, the 3 women standing there and Nancy as well. You know, I felt it coming to the outer heliosphere. I came a couple of generations after, but the outer heliosphere was still stuck in the Voyager beginning of the era. And so I was one of many different, fill the blanks, coming into the Voyager team meetings. And how did you deal? I know for myself, my tools, my toolbox to deal with being different.
I didn't really feel different, to be honest with you.
That is
I
remarkable.
actually, you know, maybe I was just so sort of bullheaded and determined, and you know, I hang out with rock climbers. So you know, but I'm not saying that means that everybody has to be that way, right?
Mhm.
I think that those of us who survived tended to be fairly persistent and strong, and not to just sort of kind of ignored the egos or laughed at them. But you shouldn't have to be that way.
Right.
Right?
Well, I think I agree with you about persistence. That's important. But I mean, I'm of such an old school, older than Fran, that I really dealt with my colleagues as a hostess deals with people. That is, I was playing that role, and sometimes quite frustrated when I was with a small group at some cocktail hour or something talking about science, and I would pose a question to, maybe there are 3 or 4 men in the group. The person who answered the question would answer it to everyone else in the group. It was like, and no question got asked back in my direction. No. So it really, yeah, it just took persistence and
Yeah.
yeah.
Thank you.
Well,
for
you must have
yeah.
trained them, Nancy, because by the time I came along, what I noticed is that, you know, when they were critical, the people who were really critical were critical of everybody. And so it almost like they must have eventually picked up lessons from you, like, because they seem to be more uniform in their treatment of people. And that's what made me not feel about, like, that made me not worry about, oh, I look different, because I felt like they were trying to treat people pretty uniformly. I mean, obviously it's not, you know, 100% following that, but I was surprised it was as uniform as it was.
I have to thank Steve Seuss. He's just, Stephen is just thanking for this meeting and reading his papers. They were very intuitive. So it's not just women's papers that are intuitive, men's as well. And there is George as well, his papers. But that intuitive made a difference for me too. Coming. Thank you so much, folks. We have to wrap up. Please, we are going to send the survey again. And Rachel, you put the survey, the link to everyone in the chat. If you can take a minute and just tell us how terrible job we did and what do you want to hear next, we would love to hear. Okay? Bye, everyone. And we will be posting it on the web. And so you can come and listen as well. We have the other webinars on the web in our SHIELD website. Thank you so much for both of you, Fran and Nancy. It was delightful.
Thank you, Marav.
Thank you. Bye.
Thank
Bye.
you.
Bye-bye.